Well, welcome. I'm Jessie. I'm here at the Wolfram Tech Conference. I'm just talking with developers and other interesting people who use Wolfram technology in pretty cool ways. And I'm sitting here right now with Devendra. Could you tell me a little bit, and also the audience, a little bit about what you do here at Wolfram, sort of what your focus is on, all that stuff?
Sure. First of all, thank you, JC, for this chance to speak on Facebook. It's a pleasure to talk to you again.
I think we're
We spoke
actually on.
last year. And I'm the manager of calculus and algebra at Wolfram. I've been here for a long time. I joined in 2001, so I pretty much know everyone and every aspect of the company's work. But my main concern is our users. I'd like to help them in every way. And we have a very wide range of users. We've got students, researchers, teachers. Everyone likes to use our products for their work. And so basically, what I do is to combine a little bit of development work, some blog post writing, some online courses, and try and show how useful we can be to everyone in the world, literally. We are used quite a lot, but we'd like people to use us even more and show that really the world can be a different place if software can be brought to do what it is capable of doing.
Cool. Well, so I know you focus on calculus and algebra and Wolfram language, and I don't know if that's changed a whole lot since version 1. I know like derivatives and limits and stuff have been around in the product for a while now, but can you tell me a little bit about some of the new features and now in version 12?
Sure. Jess. So, yes, we've had derivatives and limits and that kind of thing since version 1 essentially. And really speaking, they've been pretty solid from the start. But in the period intervening, things have changed. People have requested new features. And we have had some gaps. So, in this release cycle for version 12, we've actually kind of revamped the whole of basic calculus. So, in version 11.1, we rewrote the derivative functionality to make it do things like nth derivative, so you can find the millionth derivative of a function quite easily. And then you can find multivariate limits. That's a staple topic in advanced calculus. And now, as we go up to version 12, we've actually begun improving integrate. That's the major improvement for this release, because integrate is a very well-used function. It's really a piece of artificial intelligence, how it gets everything. We don't understand ourselves. So anyone who works on integrate is taking a huge risk. But we've taken it this time. We made the documentation much nicer. So people who use calculus now will sense that what we have is much more like a textbook and really useful to them.
Can you tell me a little bit about specifically asymptotic expansion? I know that's some of the new stuff that's coming up. And can you tell me sort of what you would use asymptotic expansion for and sort of why you would want to use like asymptotic integrate or asymptotic desolve for some of these things?
Sure. So the idea of an asymptotic expansion is to try and give an approximate formula which works really well in a certain kind of regime. So, for example, if you want to find n factorial for very large n, let's say 1000 factorial, then there are very nice asymptotic formulae which work well for large values but not so well for small values. Or let's say a prime number theorem is another example of something which is asymptotic. So we have these new functions, asymptotic desolve value, asymptotic integrate, and now asymptotic rsolve value, which actually let you find simple formulae which are very powerful when you're near a certain point. That point could be 0, that point could be infinity or whatever, but they are much simpler than the actual differential equations, and they are very useful. So in fact, a lot of technology today, the whole of aerodynamics is just asymptotic expansions, because you have a certain boundary layer around your fluid, and then that creates all the motion in a very organized way. So we try and use that notion of asymptotic expansions to deliver useful formulae to our users.
So I imagine a lot of the audience is probably familiar with expansions in the way of Taylor expansions. Are asymptotic expansions just more general than that? Or Taylor expansions a kind of asymptotic expansion?
Well, let me say Taylor expansions are definitely the most basic and important kind of asymptotic expansions. So if you know Taylor expansions, you know a lot of asymptotics. So I'm sure a lot of college students know asymptotics, they just haven't heard the word. But beyond that, you might have situations where things diverge, where things kind of blow up. And then you need asymptotics in the sense of divergent formulae, which are hard to control but much more useful. So for example, there's something called the airy function, which is very useful, but which diverges, so you need an asymptotic formula. So basically, asymptotics is a generalization of Taylor series they work really well, like Taylor series, but one has to know how many terms to use. The strange thing over there is that let's say if you got 5 terms, you might get a really good answer. Now, if you take 10 terms, you might get a really bad answer. So as the number of terms increases, the accuracy might actually go down. And that's why asymptotics is really an art, it's not a science as of now.
So do we have any functionality now that allows you to create sort of formulas, asymptotic formulas from various exact functions in Wolfram language?
Yes, we do. And so, for example, if you give version 12 a sequence, a few term of sequence, it will guess a kind of recurrence relation for that sequence and then deliver a nice asymptotic formula, and it will work brilliantly when, let's say, n is 1000, whereas doing the actual calculation might run your computer out of memory. So we have lots of these examples, and they basically let you make progress in, let's say, doing computer algorithm study, or you want to do number theory, you want to do combinatorics. All those areas now require asymptotic expansion. So yes, we have lots of that in the version 12 release.
Awesome. Well, speaking a little bit more broadly with calculus, here we have a calculus MOOC now offered at Wolfram U. Can you tell me a little bit about sort of what the course entails, kind of who the ideal audience would be, students or professionals or whoever?
Sure. So the calculus MOOC came out over the last 1 year. I began recording probably around 8 months ago, and there are 50 videos over there, and the videos start with something as simple as what is calculus, and then they go on slowly to doing standard topics in calculus. But I think that this course is really good for anyone from, let's say, I would say middle school all the way up to college and adulthood. And in fact, I'm watching this course with a 13-year-old right now to figure out how she follows it. It's going really well. I get some questions, so I know where to improve. But I think this course is designed for a very broad audience. People should learn calculus if they can, and here's an opportunity for you to do it kind of free of charge. A lot of work has gone on. We have got excellent training and video teams which put in a lot of effort into this kind of course. So the calculus course begins with the basics and then goes on rapidly all the way to cover what we call AP Calculus AB in this country. That's a pretty challenging course. So by the time you finish, you'll have done quizzes, you'll have done problem sessions, an exam, and you'll be ready to take on calculus either at school or college where you want to study it.
So, okay, so it's free, first of all, so that's great. But is it also sort of interactive? How are these students, how would they be learning calculus sort of during these lectures?
Sure. So when you watch a video, naturally you want to try things. So you can, we give you a scratch window where you can basically try all the examples. They work just as they do in the video. You can change the example. You can try examples of your own. So what you have really over there is a perfectly interactive thing, like a notebook kind of interface where you can try what you want to and improve your skills as you go along. But there's no fear, there's no exam, there's no instructor telling you what to do. You work at your pace, enjoy yourself, and when you're done, we can give you a very beautiful certificate, and hopefully one day that will inspire you to become a really good mathematician and break new ground in this area.
Cool. Can you tell me maybe about some new upcoming features, either related to asymptotic expansions or more than that within calculus and algebra?
Sure. So I'll mention two of them. One is that people who do calculus or even pre-calculus want us to tell them things like when is the function continuous, when is there no break in the graph of the function, and we'll have that kind of very simple functionality coming out very soon. And another area is what we call linear algebra. So linear algebra is the study of, I would say, linear equations and geometrical things like planes and lines. And linear algebra is central to everything. If you want to learn machine learning, you want to do data science, you want to do engineering, you want to do anything, then linear algebra and calculus give you the background for doing them. So we've done calculus now, and we work in linear algebra, and over the next 1 year, we'll have lots of stuff to show you which relates to linear algebra, and hopefully if you have linear algebra and calculus done, you can have a career in data science or what you'd like.
Awesome. Well, thanks, Devendra, for taking the time to talk with me. Anyway, thanks for watching this live stream. Anyway, do you have any final words for the audience?
Yes, I just want to say that what we have in the Wolfram language is a wonderful way to learn mathematics and its applications, not just what I do, but image processing, neural networks, statistics. And if you can make use of that to somehow blend with your own studies and get yourself a nice career, we'd be thrilled. We are here to help you, and we're always with you. So good luck in what you do, and that really is my message to the audience today.
Awesome. Thank you.